This is one of Australia's greatest commodities, abundant sunshine. It's good enough to be bottled and sold, and soon it will be. CSIRO's National Solar Energy Centre has found a way to transform sunshine into solar power that can be captured, stored and exported.
The aims of the Solar Centre are to really set up both a national and an international approach to appropriately using Australia's solar resources. It has never been properly pushed before because of our wealth of fossil fuels. But now we're seeing a need to combine the best of both worlds, fossil fuel and the solar energy. And if we can pull them together and bring it off, this will be an amazing project.
On any day in almost any Australian town, factories, cars, homes and offices are busily spurting greenhouse gases into the environment. It's now indisputable that if these emissions, particularly carbon dioxide, aren't curbed, there will be disastrous effects on the world's climate. There are changes that can affect our dependence on fossil fuels, but they need strong support, public education and innovative science. And at CSIRO's Solar Energy Centre in Newcastle, New South Wales, innovative science is establishing exciting new solar thermal technologies. Stage 1 of the centre is a modular solar array. These 200 mirrors, called heliostats, reflect the sun's energy to a reactor mounted on a specially designed 26-metre tower. This concentrates the sun's energy to create temperatures of up to 1000 degrees Celsius. The type of reactor used on the tower determines how the solar power is used. For example, at peak generation, this particular prototype could supply enough energy to power more than 100 homes. An area of 50 by 50 kilometres could supply all of Australia's electricity requirements in the year 2020.
We're trying to expand the uses of solar energy so that not only can it generate electricity and hot water, but also carry out desalination, can carry out solar cooling and air conditioning. Plus our flagship project is of course the solar gas work. One of the big problems with solar energy is that you have to use it when the sun is available. With solar gas we can actually store the energy in chemical bonds so that solar energy can be transported and stored and used whenever we need to use it.
By using reforming techniques, a new fuel has been created. By operating the solar reactor at around 600 degrees Celsius, the reaction between water vapour and methane produces a hydrogen-rich, high-energy synthetic gas called solar gas, with around 26% of its energy content from the embodied solar energy. Solar gas can be stored and transported anywhere in the world for use in a variety of applications, including industry, electricity generation and transport, and can be mixed with natural gas for use in conventional gas appliances. Combining solar and fossil fuels is an achievable way to lower emissions until renewable energy assumes a greater share of the overall energy mix.
So the project needed to be quite flexible. So the towers could be constructed out in the middle of the outback, so therefore in very harsh conditions, but they could also be constructed in major metropolitan areas. The biggest challenges, I guess, were trying to interface all the competing design criteria. We wanted it to be low cost, we wanted it to be able to integrate into an urban environment, and we wanted it to be aesthetically pleasing.
In the future, solar arrays such as this could be installed in places such as the rooftops of large car parks. The car park could then double as a service station, supplying solar-generated synthetic fuel.
This project has been voted one of 10 international projects of importance by the International Partnership for the Hydrogen Economy, and that gives us that international exposure besides what we're doing on the national scale here. It's only a step, but we are in this project really trying to combine the best of both worlds, the best of fossil fuels and the best of solar energy. This is a unique approach and certainly one that we think will carry us forward into the future.